Hi everyone, this is Miss Graham, and today we are going to be looking at Lesson 3.3, Compound Inequalities. So go ahead and pull out page 43 in your textbook, and we're going to go ahead and get started. Let's go ahead and highlight our learning targets for today. So we are going to graph compound inequalities, and we're also going to solve compound inequalities. Probably we'll start with figuring out what are compound inequalities first. If we look below, we can start by reading that compound inequalities are two inequalities that are joined by the word and or the word or. So a good way to kind of describe a real life example that goes along with this is, let's say you're ordering food at a fast food restaurant and they ask you what type of drink you want. You could have a Coke or a Sprite. Now, sometimes they'll say, hey, guess what? Maybe you're ordering a burger. You can have a burger and fries. So we're using and to include both of those two food items, whereas when we're looking at the drink, you can have one or the other. If we continue reading on, we can see that inequalities joined by the word and are actually called conjunctions. Inequalities joined by the word or are disjunctions. And I'm going to go ahead and write that in the margin to our right. So we're going to say conjunction has the word and we're going to say disjunction has the word or. Now remember, we can represent inequalities using words, symbols, or graphs, so we can also represent compound inequalities using words, symbols, or graph as well. Let's go ahead and start looking at the table below here. So we're going to be filling in the missing pieces of our table, and the first two rows have been done for us, but we're going to break this up into parts. So let's start off looking at the first row. We have some type of verbal description, some possible solutions, our inequality, and our graph. So if we look at the second row below, we're going to start looking at a verbal description of all numbers from 3 to 8. And it uses the word inclusive, meaning everything. So not just 4, 5, 6, 7, but we could say 3.5, 5.5. Maybe I could even say some of the smaller decimals. Maybe I could say, 7.65821. Or even I could say the smaller fractions in between those. So that's what we're looking at, those numbers. If we look at the next part, I actually listed some different number examples. As we can see, there's decimals included and there's fractions. If we keep going on in our row, we can see how we can write these types of numbers as two inequalities. All numbers that are going to be bigger than or equal to 3, and all numbers that are going to be less than or equal to 8. Remember, we can include 3 and 8. So now looking at our graph in the last part of our row, we can see that we're not shading where the arrows are. We're not continuing on into infinity in one direction or the other. We're looking at all the numbers between 3 and 8, and that's why there's a closed circle on each of them. So here's what you're going to do. You're going to go ahead and look at 2 rows below, and you are actually going to complete some possible solutions, the inequality, and the graph. So go ahead, pause right here, and fill in all of these spaces in regards to this verbal description. So for some possible solutions, I listed some here. You don't have to have the exact same ones as me, but remember, we're looking at numbers that are greater than -1 and equal to 4 or less than. So keep in mind, we're going to be writing 2 inequalities, just like what we did above, and they're going to be held together by the word and. So remember, we want all numbers that are greater than -1. So think about how we can write that. That's going to be x is greater than 1. Oops, sorry, not 1, negative 1. There we go. And then think about the next stipulation. They have to be less than or equal to 4. So our numbers x have to be less than or equal to 4. All right, let's say we wanted to graph this on a number line. I do have to make sure I include a negative 1 and 4 on my number line, and I space them out accurately. I also added a number 1 more to the left and 1 more to the right of these base numbers. So keep in mind, we have to graph these two together on the same number line. So starting off with looking at x is greater than negative 1, we know that means we're going to have an open circle at negative 1. Eventually, we are going to shade. We want all our values to be bigger than. So I'm moving to the right. Now, let's say I wanted to look at now x is less than or equal to 4. That means I have a circle at 4, and it is a closed circle, a shaded circle, since it includes 4. And I want to go ahead and shade in the direction to the left because I want all my values equal to or less than 4. So look at this. My arrows are pointing to each other, so I can go ahead and I can connect them to reveal that, hey, this is my shading inside. I'm looking at all the values between negative 1 and 4. It includes 4, but not negative 1. Now, let's go ahead and go up to the row right above the one we just did. I'm going to outline it in red, and we're going to go through this example now. So we want to look at all numbers less than 5, but greater than 10. So I put down a couple of examples here, like we talked about, all numbers that could be less than 5 or greater than 10. Now we know we're going to be having two inequalities, so I have them written down here. The difference between this is we have an or statement. Well, why is it an or statement? Well, think about this. Can something be less than 5 and greater than 10 at the same time? No, it can't. It's like that Coke versus Sprite situation. You can have one or the other. You can't have both. So this picture is going to look a little bit different. So if we take a look at our graph, whoa, we can see we have an open circle at 5, an open circle at 10. And guess what? If we want all the values to be less than 5, we're shading that way. If we want all the values to be greater than 10, it's that way. So that's why our numbers are going to be in this section or this section. So that's why it's an or statement. Go ahead and look at the last row. Look at our verbal description, and I want you to complete the bottom row. All right, I put down a couple of examples of numbers that would be less than or equal to 3, but also greater than 6. I went ahead and wrote down my two inequalities of x is less than or equal to 3 or x is greater than 6. And then last but not least, what I'm going to do is I'm going to have a closed circle at 3 on my number line. And I want to shade everything that is less than that. I'm going to have an open circle at 6 on my number line, and I want to shade everything above that. So I have my arrow going to the right. So you can see, kind of from looking up above what we learned about conjunction and disjunction, we can see that numbers 1 and 3, those kind of first problems we did, 1 and 3, those are going to be conjunctions. So let's label those. So that's a conjunction. That's a conjunction. So that contains the word and. And then our second and fourth example, those are going to be disjunctions. So let's go ahead and write that down to label those. Let's go ahead and go down to number 2, the table below. And we're going to kind of compare our examples that we looked at up here. We're going to look for similarities and differences between our conjunction and disjunctions above. So look at maybe our graphs. Maybe we're going to have some comparisons of that. Maybe we're going to look at some of the words and see some comparisons of that. Go ahead and list what you find here, and then we'll go ahead and go over them together. All right, let's go ahead and check some of the things that I wrote down with what you said. So we know some similarities are that there is a number line. It shows ranges of numbers, not just one number. And we know there are points at each of some of the ends. In comparison, our and graph, our conjunction, really has a region where the shading stops. Whereas our OR graphs, our disjunction, it moves in opposite directions. If you turn to the next page, there's actually a real-life example problem that looks at Spartan Middle School again and talks about, instead of the girls' fitness level test, it talks about the boys' fitness level test and seeing what they have to do in regards to a mile run, push-ups, and pull-ups. We're going to skip this so we can have a little bit more practice with compound inequalities in regards to solving them as well as graphing them. So you can go ahead and skip this page and jump to page 45. So on page 45, we can see there actually is an example above that we can look at, that we can go through to kind of break apart step by step through each of these compound inequalities. Now, keep in mind, it might be better for us to try some of these problems together. I just wanted to point this out as a resource in case you wanted to look at how it's broken down step by step. What we're actually going to do is we're going to do the try these B at the bottom, and I'm going to give you a heads up. There's not a whole lot of room here, so we're actually going to do it in the margin off to the side. So I'm going to rewrite each part there. All right, so I wrote down part A in the margin over here, and I'm going to zoom in so we can talk about it. And you're probably looking at this and saying, wait a minute, Ms. Graham, we haven't looked at a problem where there's two inequalities within one problem, right? We've usually broken it up into two pieces. And that's what I'm going to tell you what we're going to do. Mathematicians, sometimes we're a little bit lazy, and we like to kind of put together some of our inequalities just so it's easier for us. But sometimes that can be a bit confusing. This one statement is actually a conjunction. It actually is going to be two different inequalities where we use the word and. So we're going to rewrite that. Let's focus on the first half. So we have -1 is less than 3x plus 5. So let's go ahead and write that down as a little bit separated. So -1, let's not pull out the highlighter. So we have -1 is less than 3x plus 5. And then we're going to go ahead and fill in the other part where we take that same 3x plus 5. And it's going to be less than 6. So we're going to go ahead and write that down as well. 3x plus 5 is less than 6. This middle part right here, the 3x plus 5, is kind of like, if you're thinking of a sandwich, it's like your peanut butter and jelly. It's holding the two end pieces together, those pieces of bread, the -1 and the 6. And rather than just try to work it all together like this, right, where we have it all in one statement, we're going to go ahead and break it up into two inequalities and work on solving those. So we should be pretty familiar with how to solve inequalities. Remember, we're treating the inequality sign like an equal sign, right? So it's like an equal sign that we're looking at for both of them. So we're going to apply those rules of equality that we learned to our inequality. So probably the best thing for us to do here is maybe start off by subtracting 5 from both sides. So I'm going to go ahead and subtract 5. So that way now I have -6 is less than 3x. And my next step to get x by itself is divide by 3. So that way I have -2 is less than x. Now, I know most of the time I really suggest for you to solve these inequalities by putting x on the left. It makes your life a lot easier. But sometimes that's not always the case. So we may have to rewrite this again, all right? So if we rewrote this with x on the left, think about how -2 is less than x. So that means all of our x values have to be bigger than -2. So I want to say x is greater than -2. Go ahead and I want you to solve the second inequality and figure out what that's going to be. All right, hopefully this one was a little bit easier since x was already on the left side. When we solved for it, we ended up getting x is less than 1/3. So maybe some of you put that in the calculator and you got your decimal of 0.3 repeating. Totally fine. It might be a little bit easier to graph that 1/3. So guess what? Remember, the important part of this is that we are taking both of these inequalities, both of them that I have right here, x is greater than -2. and x is less than 0.3, or again, we could also say x is less than 1/3, and we're going to put them together on a number line. So let's go ahead and draw our number line. So let's go ahead and draw a number line. Now, remember, we want each of the numbers to be evenly spaced. We know we're going to have something that's a little bit less than 0, something that's a little bit more than 0. So sometimes I will put 0 in the middle, and then I will go ahead and start putting tick marks in each direction so that way you can kind of follow suit. I'm just going to go by whole numbers here because I don't have to graph my circles exactly on the whole number. I can put an estimate. So let's start off with the inequality on the left. X is greater than -2. So that means we have an open circle at -2. Remember, I want all my x values to be greater than -2, so I'm shading that way. Keep in mind, we also want x to be less than 1/3. So find 1/3 on your graph. Ooh, okay, we can see it's probably going to be here. And wait a minute, I can't have a closed circle. I need to have an open circle, right? And I'm shading all the values to the left. So wait a minute, we're looking at all the values in between here. That's kind of where our overlap is. And I apologize, my circles are a little bit different in shape. They should both be open circles though. So that's the area that we are looking at here. All right, so we are able to take kind of a really confusing, inequality that has those two signs. We could break it up into our and statement. And then remember, we're looking at here and here. We're looking at both of those inequalities. So I really should have and between these two. Now, we're going to go ahead and try another one of these right here, and you're going to try it on your own. We're actually going to jump to part C because part C is going to be another inequality where we have the and. So I'm going to go ahead, move it over to the margin right here, and I'm going to go ahead and write down part C. So part C, it starts off with 3 is less than 2 times x plus 5, which is also less, not less than yet. We're also then going to be subtracting, wait, hold on. I'm looking at this problem. I already wrote it down wrong. Oh my goodness, I need to back up a little bit. So we have 3 is less than 2 times x plus 2. Then outside the parentheses, we're subtracting 7. And then we have is less than or equal to 13. Whoa, I'm glad I double checked that. So here's what I want you to do. Similar to part A, I want you to split it up into 2 inequalities using the and. I want you to solve both inequalities. And then I want you to go ahead and graph them on a number line. Remember, we're going to see a region where it's connected by 2 endpoints. We're going to have a region where we're going to have our solutions. All right, let's go ahead and check our answers. We should have gotten the inequality x is greater than 3. Again, I rewrote it so that way my variable's on the left. And I got x is less than 8. So when I graph this, I have an open circle at 3. I'm shading this way. I have a closed circle at 8. I'm shading that way. And hey, guess what? They're going to overlap. The arrows are going to meet together. And voila, I have this middle shaded area. So that's my conjunction. Now, these are the only 2 problems that we're going to look at on this page 45 because they're looking at conjunctions and. So let's go ahead and flip to the next page, 46. All right, now we're going to be looking at a disjunction. So ready? We have our example up here that you can look at for reference, but we're going to go ahead and try A and then see if we're going to try B, or maybe we're going to have a different problem we're going to look at. So I'm going to go ahead and write part A off to the side in the margin. Now, the difference between our disjunctions versus our conjunctions on the last page is that they actually already have 2 separate inequalities for us. That's super nice because remember, we want this or this situation, right? Just like Coke or Sprite. Now, the hard part is, in our last couple of problems with conjunction, we really were doing the same steps on each inequality, right? Maybe we were adding 3 to both sides, or maybe we were dividing by 2 to both sides. In this case, we really have two separate inequalities where we're going to be not always doing the exact same steps. So let's go ahead and zoom on into our picture and start figuring out how we can solve these. So remember, for a disjunction, we look at these separately. So best thing I can do for my first inequality is subtract 1. So I get 5x is greater than 10. And then I can divide both sides by 5. So I get x is greater than 2. That's looking great so far. Remember, these are going to be separated by an or. So let's go ahead and look at our next inequality. We're going to add 1 to both sides. So now I have x is less than, oh, this is nice. X is less than -3. And that's it. That's all I have to do for that one. So the last piece that we're going to do is we're going to go ahead and graph these on a number line. So I'm going to go ahead and make my number line. I want to make sure to include all the numbers that are in there. So I have -4, -3, -2, -1, 0, 1, 2, 3. So let's look at our inequality on the left. I have x is greater than 2, so I have an open circle at 2, and I'm going to shade all the values greater than. So make sure you put an arrow on the end because it keeps going. Then I'm going to look at my inequality on the right, and I want all the x values that are less than -3. Again, it's an open circle at -3, but I want to shade towards the left because I want all the values less than that. Remember, disjunctions is not one solid area. It's kind of like moving in two different areas. You want this or that. Now, I am going to have you try part B below, but I want to give you a heads up. It's a little tricky. So part B down here, I'm going to write it off into the margin, is a little tricky. So part B is going to be -5x is greater than 20. Or it's going to be x minus 2 is greater than -7. So my hint before you solve this, my hint to you is be careful of this negative out front in front of the 5x. All right, go ahead, see if you can solve the inequalities and graph it on a number line. All right, so let's go ahead and try out this problem. As you can see, remember, whenever we divide by negative, the sign flips. So I have x is less than -4. I know, so tricky. So if we put this on our number line, right? Open circle at -4. And we would be shading to the left. Wait a minute. This is looking interesting. Okay. We solve on the next one. X is greater than -5. Wait a minute. That means we're shading this way. Hold on. This is a little confusing. This should be an or statement, right? But that means I could keep going above each of these. So this one's a little bit of a tricky problem. You know why? Because guess what? We're not just going to have this middle shaded area right here. We're actually going to have all of the points. It's kind of confusing because think about this. Ready? Let's say we wanted to look at x is less than -4. We want to shade everything this way. But then wait a minute. So let's say I wanted to do x is greater than -5. We shade everything this way. Look at this. All of our points are covered, the whole basis. So really, we're kind of shading the whole entire number line. I know, this was such a tricky one. Do not worry. I know some of you needed a little bit of challenge with this. If this was a little too hard, don't worry. I'm going to give you one more to try on your own. That is a disjunction. All right, so I kind of took this problem up here and modified it a little bit. So I want you to go ahead, write the new problem down, and then I want you to try figuring out how to solve it and graph it on a number line. All right, go ahead and check your work and your graph with mine, and you should have the matching disjunction function. All right, we got one more tiny last practice problem. It's going to be number 4. Right under here under check your understanding. So it shows the solutions of a conjunction. Ooh, okay, it's a conjunction. So remember, we're using the word and. All right, it's graphed below. We want you to write down what the inequality is. So remember, that means we're going to have two parts. We're going to have this and this. So go ahead and see if you can take this inequality from the picture and put it into symbols. All right, since we're starting off at 0 and moving to the right, keep in mind 0 is not included. And we're looking at all the x values bigger than 0. So x is going to be greater than 0. But wait a minute. Keep in mind we have the stopping point up here. It is including 5, but we want all the points less than that. So we also want x is less than or equal to 5. It really doesn't matter which one of these you put first, right? Just like, hey, I could have a hamburger and french fries, or I could have a french fries and a hamburger, all right? So keep that in mind, though I try to work from left to right there, just to make it a little bit easier. All right, so there you go. We got some compound inequalities on our way, and don't worry, we will be practicing them in class tomorrow.